Dear students, in this lesson I'm going to make some calculations and come to some conclusions by the end of the lesson. Please watch carefully, and actually it would be better if you had a paper and pen and do calculations together with me. Now my starting point is I have a big right triangle and there's a small one inside that big right triangle. I'm going to give some names to the corners of these triangles. Let's call this corner, for example, A. This could be B, C, D, and E. I'm also going to draw a couple of lines inside these triangles. First one is this one, which is also going to be 90 degrees here, and the second line is this one, and third line is this one here. Now let's calculate the area of the triangle ABD. The area of the triangle ABD is going to be equal to, if I choose the base to be AB, then multiplied by the height is going to be BD divided by 2. But at the same time I can also choose AD to be the base for the same triangle, and if I call this line here H, it's going to be the height of the ABD triangle, so AD times H divided by 2. Now I would like to calculate the area of the triangle BCD. The area of the triangle BCD is going to be the base BD times the height is going to be CB divided by 2. Next, I'm going to calculate the area of the triangle BDE. Again, the base is going to be BD and the height is again actually CB divided by 2. So are you able to see that these two triangles have the same area? I hope you're able to see that CB is also the height of the triangle BDE, just like it is the height of the triangle BCD. Next, I would like to calculate the area of the triangle ACD. The base is going to be AC and the height is going to be BD. This is actually the sum of the areas ABD plus the area of the triangle BCD. Next, let's calculate the area of the triangle ABE. The base is going to be AB. The height is going to be CE divided by 2. But at the same time, I can choose AE to be the base, and in that case H is going to be the height of the triangle and divided by 2. I can also see that this area is actually the sum of the area of the triangle ABD and the triangle BDE. Now I want you to be careful about something here. The area of the triangle ACD is equal to the sum of the areas of ABD and BCD, and the area of the triangle of ABE is the sum of the triangles of ABD and BDE. Now we can see that ABD areas are common, and also we have proven that the areas of the triangles BCD is equal to the area of the triangle BDE. On one side we have BCD, on the other side we have BDE. Then we can actually say that the area of the triangle ACD is equal to the area of the triangle ABE. So I can put these two equations together. I can say that AC times BD divided by 2, which is this one, is actually equal to AB times CE divided by 2, which is this equation. Now these twos cancel each other. I'm going to divide both sides to AB. These ABs cancel each other. And I'm going to divide both sides again to AC. And this time, these ACs cancel each other. So eventually what I have here is BD divided by AB is equal to CE divided by AC. Now we have an angle here. Let's call that angle theta. From theta point of view, what is BD divided by AB? This is an angle in a right triangle. It is actually the tangent theta. It is also equal to CE divided by AC. Now, can you see that tangent theta is the same regardless of the size of the triangle? Doesn't matter how big your triangle is or how small it is, tangent theta is going to be constant. By constant I mean tangent theta is not going to change with the size of the triangle you have. Let's keep going. Now in this equation, the twos cancel each other, and I'm going to divide both sides to AD. ADs cancel each other, and I'm going to divide both sides also with AB. Now these ABs cancel. I also have this equation here, and this is the area of the triangle ABE. So from this equation, twos cancel each other. I will divide both sides to AE. These two cancel. I will also divide both sides to AB. These two cancel. CE divided by AE is equal to H divided by AB, and this is coming from here. And this one is coming from here. Now you can see that we have common term here, which is H divided by AB. If both expressions are equal to H divided by AB, then they are equal to each other. BD divided by AD is equal to CE divided by AE. Now back to the angle theta here. BD divided by AD is sine of theta. It's also equal to CE divided by AE. Now you can see that sine of theta is constant regardless of the size of the triangle that you're working on. This is very important. Now I will do one more thing. First, I will again use this equation here. This time, first, I will divide both sides to AD. These cancel, and again divide both sides to BD. Previously we had proven that the area of ACD is equal to the area of ABE. So from here I can take this part and say that it is equal to the area of ABE, which is AE times H divided by 2. Twos cancel. Now I will divide both sides to AE. These cancel, and I will also divide both sides to BD. These two cancel. Now this term is equal to this term. Then this must be equal to this. Let's write it down in a clear form. AB divided by AD is going to be equal to AC divided by AE. From the angle theta point of view, AB divided by AD is cosine theta. Just like tangent and sine, cosine is also regardless the size of the triangle that you're working in. It doesn't matter how small your triangle or how big it is, cosine theta is constant. So tangent theta is a value, sine theta is another value, and cosine theta is another value, but they are always constant. Doesn't matter how big or how small your triangle is. Since tangent, sine, and cosine are constant, of course cotangent, cosecant, and secant are also going to be constant, because remember, those are the flipped versions of these trigonometric functions. This was a very important consequence, and we are going to see how important this is. I hope you were able to follow this lesson, and I strongly suggest you to repeat these steps by yourself, and whenever you feel like you're confused, come back to the video and get some help. Let's go to the next lesson and keep learning. Thanks.